Solving optimization problems.
In order to solve some optimization problems, here is a summary of the steps that you need to follow. First, make a sketch of the problem and assign variables to all the quantities involved. Second, translate all relationships into mathematical equations. Third, plug one equation into the other and simplify. Fourth, take the derivative of the new equation, set it equal to 0, and then solve.
To fully understand this lesson, let us look at some examples. A new attraction for the Manila Ocean Park is being created. Engineers are planning to make a box-shaped aquarium with a square bottom and an open top for it. The aquarium must hold 500 cubic feet of water. What dimensions should they use to create an acceptable aquarium with the least amount of glass? First, let us draw a box with a volume of 500 cubic feet, length and width labeled with variable x, and height labeled with variable y. Since the volume is equal to length times width times height, the volume of this box would be 500 equals x times y, or 500 equals x squared y. We call this equation as the constraint. For the second equation, we need to find the surface area of the box, which is the sum of the area of each face. Since our box is an open top, we are going to have 5 faces. So, the area of the bottom is x times x, or x squared, and the area of the side is x times y. Since there are 4 of them, it would be plus 4xy, and this would be the equation we want to minimize. For the next step, we need to write s in terms of one variable. To do this, we need to rearrange the constraint and plug it into the equation we want to minimize. We need to isolate y by dividing both sides by x squared to get 500 divided by x squared. We are going to plug this into the surface area function and simplify. And we get s equals x squared plus 2000 divided by x. We derive s and we get 2x minus 2000 over x squared. Equate the derived function to 0, solve for x, and we get x equals 10. Now that we have solved for x, we are going to substitute this to the y function to solve for the y value. So y equals 500 divided by 10 squared is equal to 5. To verify our answers, let us look at the graph of the function of the surface area in terms of one variable. Notice that the minimum value of the graph has the coordinates of 10, 300. If we substitute our x value, which is 10, to the formula, we get a surface area of 300. Thus, it shows that our solution is correct. Therefore, the dimensions that they should use are 10 feet by 10 feet by 5 feet, and the minimum surface area of the box would be 300 square feet.
Created using Part1.